All right, so let's look at the problem session, and hopefully you did well on these. And remember, I want you to grade. I want you to put the +1s when we come to the free response. But the multiple choice, you have a function that has derivatives of those things. And so this one you can tell if I'm looking at f prime, I'm going to do it over here so I have the space. F prime number line, I can see this is equal to 0. So not that you have to write this down at x equals 0 and 1. So I'll put that on my number line. And then I'll do a sign analysis. I won't plug into x squared because I know x squared is always positive anyway. So if I plug into 1 minus x, if I have a number that's less than 1, I'm going to have a positive value. And then if I have a number greater than 1, I will have a negative value. Then I'll go ahead and do f double prime. I see that it is equal to 0 at x equals 0 and 2/3. So I'm going to do an f prime, double prime number line, and I'll try to line it up just to make myself think properly. I'll put 2/3 right where it is. I kind of have them all lined up. And in that one, I know that that's going to be a negative x squared if I thought about multiplying that out. Or I could plug in numbers and I would get negative, positive, and then negative. So let's see what I'm looking for. Over which interval is the graph both increasing and concave up? So I need f prime to be positive and f double prime also to be positive. So where is that place? So that place, of course, f prime being positive, I have these two sections. However, if I need f double prime to also be positive, then I will have right here between 0 and 2/3. And so that's going to be my correct answer. All right, let's look at the free response. Now remember, as you grade, I'll go ahead and do the +1s kind of as I go each part, and I want you to put the +1s. And if you don't get all the points, then you need to have corrections in red. So it says a circle is inscribed in a square as shown in the figure below. The circumference of the circle is increasing at a constant rate of 6 inches per second. I see that and I'm like dc dt is equal to 6 inches per second. As the circle expands, the square expands to maintain the condition of tangency. So in other words, I'm just blowing up that picture and it stays inside the square, etc. And then it gives you, of course, circumference and area formulas. Find the rate at which the perimeter, so in letter A, to get myself organized, find the rate at which the perimeter of the square is increasing. I can read. So in other words, find dp dt. Now, I will say there are several ways to do this. Okay, different people, you could get a formula for perimeter in terms of circumference. So there are a couple ways to do this. I'm just following my thought process. So we'll just kind of go there. We'll look at the final answers. If you get the final answers, then you'll probably have it right. So find the rate at which the perimeter of the square is increasing. So find dp dt. Well, immediately I go, okay, well, let me do an equation for p. Well, what is the perimeter of the circle? Well, if this is 1 radius, of course, that means the radius, here's 1 radius, which of course, so the whole thing, the whole square, I think you can see would be 2r, the whole length of the square. Well, of course, I have 4 sides of that square, so I have 8r. Now, dp dt then would be 8 dr dt. But then I think to myself, well, I don't know what dr dt is. So once you take the derivative, remember, or as we've been saying before, is that, okay, if you have to go fill in, but you don't explicitly know the stuff, they've given you enough to find it. Well, that's when I would come over here and say, well, I know that c is the circumference, is 2 pi r. So if dc dt is equal to 2 pi dr dt, and I know that dc dt, because the given is 6, then notice I could solve for dr dt. Now be careful how you write this, would be 6 over 2 pi or in other words, 3 over pi. And then I can pop that in, this in for this dr dt, and I would get 8 times 3 over pi. So dp dt, I could technically leave it like that, but that's not too hard simplifying. I'm going to talk about points in just a second, is 24 over pi. And then the units, what would the units be? Well, you would measure perimeter in inches. So that's going to be inches. What was my time units? Seconds. So that's going to be inches per second. Now, where are the points? Again, because you could do it differently, this question, letter A, was worth 4 points. So here's what we got. Okay. And remember, in related rates, I kind of ask you to write a sentence. Not that you have to, but, I always like to find the rate at which the perimeter is increasing. The perimeter is increasing at a rate of 24 over pi inches per, not pi, inches per second. Okay, so here's the point count. Your relating equation is worth 1. Now, if you somehow you have to solve for dr dt, and you would get a point there. For taking the correct derivative, you would get a point. And then you have a final point for the answer and the units. Again, if you did it differently, where you solved and got the perimeter in terms of c, you could do that. And then if you took the derivative correctly, then you'd get a point for that, etc. So those are those 4 points. Now, the next question says, at the instant when the area of the circle is 25 pi square inches, find the rate of increase in the area enclosed between the circle and the square. So let me think about what they're talking about. Let me kind of erase this and see what they mean. I'm looking for the chain, how this area is increasing, the area enclosed between the circle and the square. Again, many ways you could write this. I have to be very thoughtful in how my process of thinking this through. So I'm like, okay, they want the area enclosed. So to me, I'm like, okay, I'm going to call that AE, the enclosed area. Again, your variables don't have to match mine, but the area enclosed would have to be the area of the square minus the area of the circle. Again, you could do 2 different things and subtract at the end. I'm going to do it in one fell swoop, but you can do lots of different things. I go, okay, well, what are those things? Well, the area of a square, I'm doing mine in terms of r, would be 4r squared. Okay, the area of the square is 4r squared, because again, we said that one whole side was 2r. So the area of the square, of course, would be 2r squared or 4r squared. Minus the area of the circle, we know that that is pi r squared. Now, what would the derivative be? Because I'm looking for this amount. That would be 8r dr dt minus 2 pi r dr dt. And the nice thing is, in letter A, I already found dr dt. So I'm like, I'm looking pretty good. I'm gonna plug in my stuff, but I quickly come to a oh shoot, because I don't know r. If I start plugging in, this is what I have. I'm kind of plugging in what I know, because then I think, well, what am I missing? I'm missing r. But they told me, I haven't even used my given, at the instant when the area of the circle is 25 pi. Well, if the area of the circle is 25 pi, then that means I can solve for, you could probably do this in your head, but I'm just making sure you're following me. then I think we can see that in that instant, r is 5. So I'm going to plug that in here and go from there. And so what it ends up being, remember, I technically could leave the answer like that. I am going to simplify just a little bit because I like you to write a sentence. When area of the circle is 25, I'm going to do some pi inches squared. The enclosed area, whoa, calm down. That says enclosed. The closed area is increasing at a rate of, now I'm going to simplify a little bit. Technically, could I write the answer like this? I totally could. I'm going to do just a little bit of simplifying. It's not too hard. 8 times 5 times 3, that's 120. That's 120 over pi minus, those pi's cancel, 2 times 5 times 3, that's 30. I'm going to write it like that. Again, you don't have to do that. Simplifying, you can get a common denominator. I would just leave it that way. And then what would be the units? The area of a circle, I'm talking about an area, so it's going to be inches squared per second. So where are the points on that? Again, you might not have done it in one fell swoop, but you get one for the relating equation. So if you did 2 different relating equations, then of course, did you do both of those? Then did you take the correct derivatives? Again, if you did it twice, both derivatives would have to be correct. Did you solve and plug in r being 5? If you did that, that was a point. And then, of course, the last point, well, the last point in this one is this answer right here. Now, the last point in this one is actually, if you count up, you're like, well, Miss Pruitt, that's only 8 points because I have 1, 2, 3, 4, 5, 6, 7, 8. Where's the other point? The last point, and I should have said this, I'm sorry. This point right here was for the number only, the 24 over pi. The last point is for units in parts A and B. In other words, did they have inches per second on A and inches squared per second on B? They have to have the correct units in both. So if they missed one, then they didn't get that point. So that is the total of 9 points. All right, let's do the next one. If the first derivative is greater than 0 and the second derivative is less than 0 for all values of x, which could be a table of values for f of x. Well, let's see what I know. If the first derivative is greater than 0, I know that f is increasing. Let me just by that token, let's see if I can knock out some things. If I look at values, I can knock out a, because look at the y values of a. He's out. He's out. Okay. If the second derivative is negative, that means that f prime, it means that f is concave down. Okay. That kind of doesn't help me because I don't really know about f, but I would know that f prime must be decreasing. And think about what f prime is. F prime is the rate of change. So if I look at like letter B, if I look at the difference between these, do you see that this difference is like +2, +2, +2? Let's do this one. This difference, if I go from -2 to 2, I'm going 4, 3, and 2. And then we'll go ahead and do this one. 2, 3, and 4. So that's telling you the change, if I found the slope between those points, then it's kind of showing me the change. Notice that each of these is going up by 1. So I can very quickly get those values. Well, if f prime must be decreasing, then I'm looking for this one right here. And so C is my answer. All right, number 4. Little implicit work again. Show that dy dx is that expression there. So I'm going to start in letter A, I'm going to start doing the implicit. So I have x squared dy dx. I'm doing product rule on that. First times the derivative of the second plus the second times the derivative of the first minus, again, that whole minus, you can put parentheses. I'm going to put plus and put that negative with the x. So I have plus first negative x times the derivative of the second 2y dy dx plus the second times the derivative of the first is -1 is equal to 0. Again, when it says show, friends, show your work. Okay? Okay, so I have that. Let's keep our dy dx's on the left. I would have a y squared to the right and a minus 2xy, making sure I factor. There it is. You might could hear the vacuuming outside. And then finally I divide and I get this. Double checking it's exactly what they have, and I am good. Where are the points? Well, the points are really, did you do the implicit, did you do product rule, and did you do the implicit there, and then did you show the algebraic steps and get to there? All right, letter B. Find all the points on the curve whose x-coordinate is 1. Write an equation for the normal line at each of these points. So remember, as you're doing a free response, you want to read it through once, and then if they give you a command, do what they say. Find all the points on the curve whose x-coordinate is 1. Stop and do what they say. Well, whose x-coordinate is 1. Now I'm going to erase this, and I'm going to go back to my original, and I'm going to plug in 1 for x. So if x is equal to 1, I'm going back to the original, and I would get 1 times y, because 1 squared, of course, is 1, minus 1 times y squared is equal to -6. I'm going to choose to move to the right, so my y squared is positive. So y squared would be positive. The y would be negative, and then I have -6. So I'm moving to the right, even though I write it on the left. I can factor, and I'm showing all these steps with equaling 0. So I get y is equal to 3 and -2. So my points, so I'm going to say points are 1, 3, and 1, -2. Okay, so I did what they say. Now they then said, and write the equation for the normal line at each of these points. I have to be very, very clear that what I'm doing. So I'm going to say at 1, 3, dy dx is what? So I'm going to go to, notice my notation there. Okay, don't write dy dx and start putting in numbers. I put dy dx evaluated at 1, 3. So I'm going to kind of do this in my head. I'm going to this equation right here, putting in 1 for x and 3 for y. So I'd have 9 minus 2 times 1 times 3, and then 1 minus 2, 1 times 3. So what does that give me? -3/5. Okay, so it said write the normal line. So normal line would be y minus 3. Remember, this is the slope of the tangent line. So opposite reciprocal, x minus 1. I'll do the points in just a second. At 1, -2, dy dx at that point is going to be, 4 minus 2 to negative 2 over 1 plus 4. So what is that, 8/5? So the normal line is going to be y plus 2 is equal to negative 5/8 x minus 1. So here are the points for that one. You got 1 point, again, and you have to show the factoring. You have to make sure that you're getting the y values of 3 and negative 2. So did you get that? And then you have to, I mean, it's really weird how they do it. They kind of are like, okay, did you get these slopes? So that was worth 1 point. And then did you get the tangent lines? So you had to get both. So these slopes were worth 1, and then the normal line, this one was worth 1, and this one was also worth 1. But so is that kind of, this 1 point was for getting the correct slopes of the tangent lines. All right. Now, I will tell you, if you have the wrong notation and you put dy dx equals and not dy dx evaluating, you will lose. It's kind of a notation error. You would lose that point. So make sure that you have the correct notation there. Last one, letter C. Letter C, it says, find the x-coordinate of each point of the curve where the tangent line is vertical. Okay, so the tangent line is vertical when dy dx is undefined. Now, I tend to write that. I don't think you will get points for it, but just to make sure you're with me, is undefined. Well, okay, well, when is dy dx undefined? That's when the denominator equals 0. Now, this one's weird, and I think this one's hard. Okay, if I factor an x out, I end up getting something that looks like this. So I get x equals 0, or I see x equals 2y. Now let me read the question again. Find the x-coordinate of each point where the tangent line is vertical. So it looks like 0 is an answer. But if you go back to the original, are you with me that if I kind of like when you have to find where the tangent line is a certain value, you have to make sure there is a point on this curve when x is 0. Do you see if I put in x is 0, I would get 0 minus 0 is equal to negative 6? That doesn't even make sense, meaning there are no points where x equals 0. So I have to check that. So even though I get x equals 0, there are no points like that. But let me see what I can do with this guy. Again, there's 2 different ways you could solve this problem. Being that it asked me for the x-coordinate, I tend to get everything in terms of x. So meaning y is equal to x over 2. So if I go back to my original, and I'm rewriting the original just so I don't have to scroll my iPad back up. This was the original equation. I'm going to plug this x over 2 in for every y. So I have x squared over x over 2 minus x times x squared over 4. I hope you know where I got that. Again, if y is x over 2, if I square it, I square the top and bottom, is equal to negative 6. So what do I have? I have x cubed over 2 minus x cubed over 4 is equal to negative 6. And if I got a common denominator, I think you'd be with me that I could do that really quickly. So that's really just x cubed over 4 is negative 6. So x cubed is negative 24. Yes, you get very weird answers. You get x equals the cube root of negative 24. You could write that. I would leave it alone. Yes, you can simplify that to 2 cube roots of negative 3. I wouldn't bother doing that. And this is my final answer. Okay. Now, where are the points on him? The points on him are, did you set the denominator equal to 0? If you set the denominator equal to 0, you got a point. When you got down to here, did you plug that in for y? And then the last point is, did you get a correct answer? So that was the remaining points. So make sure that you have your plus ones. For anything you did not get plus 1, you are correcting in red or blue or something that I see a difference, and that's what you are going to turn in. Y'all have a great one, and I hope you learned something. All right, toodaloos.